Okay, there's a couple of supplemental things for section 8.2 that I wanted to talk about. These are things that aren't going to come into play immediately, but they're still pretty important to know. The first thing is how to evaluate radical expressions and finding the domain. And part of the reason why these are important to understand is because they will actually help you to understand what it is that you're doing. Okay, so the first thing I want to talk about is evaluating radical expressions. Okay, so let's go ahead and go down to evaluating radical expressions. So let's say, for example, we have that f of x equals square root of 6x minus 2. Okay, so f of x equals square root of 6x minus 2. So remember, whenever we're looking for, say we want to find f of 1. So remember that whenever we're looking for, whenever we're told to evaluate f of 1, all that means is that we put 1 in for x. So let's go ahead and do this example. So we'll have square root of 6 times 1 minus 2. Let's write that like this. Whoops, I did something wrong here. Okay, sorry, forgot. Okay, so we have, all I did was I put 1 in for x, so we have 6 times 1 minus 2, and that's going to be equal to, of course, the square root of 6 times 1 is just 6, so it's going to be square root of 6 minus 2. And that's going to be equal to square root of 4, and the square root of 4 is just 2. Okay, so in this case, f of 1 turned out to be kind of a nice number. So let's try f of 2. Let's see how that one works out. So, oh crud, new line. Okay, so f of 2, so that means we just put 2 in for x, so let's say we have square root of 6, 2 minus 2. Okay, so the square root of 6 times 2 minus 2. 6 times 2 is going to be 12, so that's equal to the square root of 12 minus 2. And 12 minus 2 is going to be equal to 10. So what's the square root of 10? Well, we don't know. I mean, we know. I mean, it's an irrational number. We can't write it like as a decimal, as that's repeats or anything. We can't write it as a fraction. Square root of 10 is just pretty much square root of 10. It's an irrational number, so we're going to keep it like this. This is the most simplified form of square root of 10. So that's an example of where evaluating a radical doesn't turn out so nice, because that's as far as it goes. Now, the primes of 10 are 2 and 5, so that means we can't even pull any factors outside of the radical. So let's try f of 3. Let's see if that turns out into a nice number or if it's something that's hard to deal with. So square root of 6 times 3 minus 2. Okay, so 6 times 3 minus 2. 6 times 3 is going to be 18. So we have square root of 18 minus 2. Okay, so 18 minus 2 is going to equal 16. So we have square root of 16. And square root of 16 is just going to be 4, because 4 times 4 is 16. So that means that this is going to be the final answer for f of 3. So these are examples of evaluating radical expressions. Again, these don't come into play immediately, but the main thing I wanted to show you was that how the different answers you'll get. You know, you have 2, root 10, and 4. These are kind of strange answers. I mean, the 2 and 4, you know, they seem like normal answers, but root 10, sometimes you can't simplify them any further than that. In fact, more often than not, you can't simplify them any further than that. Okay, so let's go on to the next section that I want to talk about, finding domain. So finding the domain of a radical expression. Finding the domain of a radical expression. Okay, so the radicand, which is the number under the root, must be okay, let's see, I gotta the radicand, which is the number under the root, has to be greater than 0 for even roots. This doesn't apply for cube roots, but it will apply to square roots, it will apply to fourth roots. And why is this true? Well, this is true because let's try the square root of negative 16. Sorry, just a second. Okay, square root of negative 16. Well, what times itself gives us negative 16 back? Well, can we try negative 4? So let's say negative 4. Okay, just a second. So let's try this out. So negative 4 times negative 4, well, a negative times a negative equals a positive. So that means that negative 4 times negative 4 equals 16. So negative 4 times negative 4 is not the square root of 16. So that means that that doesn't work. So basically, whenever you square anything, you're going to get a positive number. So that means that whenever we have this negative here, we don't get a we say that we don't get a real number. Now there's an entire branch of math that goes into working with these anyway and saying we get an imaginary number. We're not going to go into that now, but just be aware for now that whenever you encounter this, whenever you see square root of negative 16, your answer is not a real number. So, because we're not dealing with imaginary numbers right now, we're only dealing with real numbers. So that means that, so to go back to the main point that we're getting at, the radicand, which is the number under the root, needs to be greater than 0 for even roots. So that means the domain, which means when we say a domain is a domain is a set, like where we can evaluate x. So let's say, for example, let's write it this way: for what values of x can we define the function? So if x is negative 4, we can't define the well, say for if we're dealing with just square root of x. So f of x equals square root of x. This is our function. We can't take the if x is less than 0, then we can't define this function. So that means that the domain is going to be x greater than or equal to 0. So let's go on to a more complicated example. Find the domain of f of x equals square root of 2x plus 10. Okay, so example, find the domain of f of x equals 2x squared plus 10. So we can only take the square root of 2x plus 10 if 2x plus 10 is greater than or equal to 0. Okay, just a second. Okay, so that means that this is what we have to work with. We're dealing with an inequality here. We need to find for what values of x will this be valid. Whenever you're dealing with inequalities, it's very similar to dealing with equations, but if you multiply or divide by a negative, you flip the sign. So we need to get x by itself, just like we would if we're solving for x in an equation. So let's try, we want to subtract 10 from both sides, so we'll get 2x greater than or equal to negative 10. Let's move this up a little bit. So 2x is greater than or equal to negative 10. I just subtracted 10 from both sides. And now I want to divide both sides by 0. So we have x is greater than or equal to negative 5. So we subtracted 10 from both sides to get that 2x is greater than or equal to negative 10, and we divided by 2, and this is a positive 2, so we don't need to flip this sign, and we get x is greater than negative 5. That pretty much concludes this. I know this is a little bit, quite a bit further along than what we're really doing right now, but if you understand this, it'll help you to understand what you're doing in section 8.1. 8.2. So that is it for now.